Hello and welcome to my tutorial. This is Humayun Kabir. Today I am going to show you how to design a column with Excel spreadsheet. For that we have to go through some steps. Those steps are introduction of the spreadsheet, performing the design with that sheet, and finally the result. So let's introduce ourselves with that sheet. This is the column design sheet and this sheet is divided into several tabs. In the lower left corner on your screen you can see those tabs. So first one is column design tab, then check tab, theories and disclaimer. I will discuss about all these tabs. So let's go to the column design tab. This tab is the heart of the whole sheet. In this tab all the calculation and design is performed. The result will be shown here as well. This page also divided into several parts. This blue color part, here we will insert our data in this black cells. Beside this blue color we can see that this is green color portion. In this green color portion we will see our result. The result will be shown in both WSD and USD method. One of the most fascinating thing about this sheet is whenever you insert a data set for a particular column design, this sheet will design three types of columns simultaneously. First one is rectangular column, then a square column, and finally the circular column. A capacity finder is also given here. With this capacity finder we can find out the capacity of a column. Just we have to put the dimension of the column here and the area of steel. The result will be shown here. A theoretical tie design is also given here. So this is all about the column design tab. Then check tab. Check tab is provided here to secure the main tab. I have done a simple problem on the column design tab and captured some image and put it in here. So whenever you put this black cells value on the column design tab, and then if you get the result same as this image on the column design tab, then you can think that this sheet is working properly. If not, please do not use this sheet. Then theories is provided here to helping or recalling our memories. These theories are collected from a lecture sheet which is provided by our university teacher. Thanks to him. Then the disclaimer tab. In the disclaimer tab I have put my simple or a small description and a message is here. One thing about this sheet is whenever you perform a design in this sheet and if you then want to implement the result of the sheet in the practical field, please verify the result or please check the result with a professional engineer. So these are all about those tabs. Let's go to the column design tab. Now we will perform a design. For performing the design I have selected an example which is given in theories tab. So let's go to the theories tab, then scroll down a little bit. This is the example. This example says that we have to design a square tight column in USD method and the loads are given. Then the compressive strength of the concrete, yielding strength of steel is also given and the steel ratio is 5%. So let's put these values on the column design tab. First one is compressive strength of the concrete. It's given 5 ksi, that means 5000 psi. Then hit enter for the next value. Yielding strength of the steel is given there 60 ksi, that means 60,000 psi. Then width of the column, because we are dealing with a square column we need not to put this value here, it's only for rectangular column. So let's leave this cell. Then steel ratio is given 5%, so let's put 5 here. Then the loads, let's go to the theory step for loads. Dead load is given 400 kip and live load is given 210 kip. Because of the code, we need to multiply 1.2 with dead load and 1.6 with live load. After adding these two load, we will get a factored load. So it's done here. The factored load is 816 kip. So let's put this value on the column design tab. 816 kip. Then reduction factor for tight column is 0.65. Then the reduction factor for spiral column is 0.70, and the steel ratio in WSD method is 0.025, and then the clear cover. So we have put all the values and that's it. Now we will see the result. Because we are dealing with the square column, let's go to the square column section. This is the square column section, and the result is width of the column will be 23 inch in WSD and 15 inch in USD, and the depth same because of a square column, 23 inch in WSD and 15 inch in USD. Clear cover is 2.5 inch. So now about the steel, it's here in here, and the amount of steel in WSD method is 12.7 inches square, and in USD method the steel is 11 inches square. So let's see the result of the theory step. It's 15 inch and 12.5 and 2.5. 2.5 is clear cover, total 15 inch. So 15 inch into 15 inch, and the steel is given here, it's 11 inches square. So it's same, so it's okay. And now we will rearrange the steel. These two lines of cells is given to rearrange our steel. So let's rearrange. 10 number of 8 bar, 8 bar, and 6 number of 6 bar. If we want to use two types of bar in the column, then it comes 10.54 inches square, which is less than the required steel. So let's increase the steel 8. It's 11.42 inches square, and we can use this steel. And what's in our theory step, let's see. They use 14 number of 8 bar. So let's see what happened in 14 number of 8 bar. 14 number of 8 bar, and it's 11.06 inches square, which is more economical than previous one. So let's use it. 14 number of 8 bar. So finally the result is 15 inch into 15 inch. The clear cover is 2.5 inch, and we will use 14 number of 8 bar. That's it. Now if we want to design a rectangular column with this data and with these loads, what will we do then? We need not to do anything, it's already done. Because previously we assumed the width of the rectangular column is 10 inch, that's why the width of this rectangular column 10 inch in both method, and then the depth is 52 inch in WSD method and 23 inch in USD method. 2.5 inch is the clear cover. Then the amount of steel in WSD method is 13 inches square, and in USD method 10.62 inches square. Now we can clearly see that the WSD method is not very economical, but USD method is much more economical. That's why WSD method is no longer in use. So let's rearrange the steel for USD method. So our steel is 10.62 inches square. So let's use two types of reinforcement here. So let's use 8 number of 8 bar and 8 number of 6 bar. So what happened? It's 9.84 inches square, which is slightly shorter than the required steel. So let's increase the number 8 bar. Let's increase 2 number of bar. So 10 number of 8 bar. So it comes 11.42 inches square, which is uh, bigger than the required steel. So let's keep it 8 number of 8 bar, and let's increase 2 reinforcement here, 10 number of 6 bar. So 10.72, which is slightly similar to the required steel, so we will use 10.72 inches square. So finally we came to the result that the result is 10 inch into 23 inch the dimension, and 2.5 inch is the clear cover, and we will use 8 number of 8 bar and 10 number of 6 bar, so total 18 bar. So this is the rectangular column design. What about the circular column? It's already done here, and we can see the result, radius and the clear cover, then the amount of steel. Now we have to just rearrange the steel here. That's it. This is all about the column design. Now let's see what we can do with this capacity finder. With this capacity finder we can find out the capacity of a column. Just we have to put the dimension and the area of steel. Let's take this column is an example, and the dimension of the column is 10 inch into 23 inch. Let's put this here, 10 inch into 23 inch, and the amount of steel is 8 number of 8 bar and 10 number of 6 bar, total 10.72 inches square. So let's put it here, 10.72 inches square for the USD method. Let's see the result. So capacity of this rectangular column is 819 kip. So our column capacity is 819 kip, and we have just designed that column for 816 kip. So this column is safe and it's okay. That means we can check the column with this capacity finder, and we can find out the capacity as well, and we can also design a column with this capacity finder. Suppose now I want to design a column which will support more than 1000 kip. Now just I can increase the dimension here, and I can also uh, increase the steel here. I have just increased the dimension, and you can see the capacity of this column is increased as well, and it's become 920 kip. Now let's increase the dimension again, 25 inch, and the area of steel, let's use 11 inches square. Let's use 13 inches square, and it's done. So if we want to design a column with this capacity finder which is bear more than 1000 kip, and that's it, it's already done, and The dimension of the column is 12 inch into 25 inch. The area of steel will be 13 inches square. And if we want to rearrange the steel, we can use these cells for rearranging that steel, and that's it. We can use like this way this capacity finder. A tie design option is also given here. With this option we can design the ties theoretically, but if we need a complex tie bar, these meshes will be shown here for the rectangular column and for the square column here. For the rectangular column in WSD method, the tie design is this one, and for the USD method, tie design is this one. For the square column in WSD method, tie design is given here, and for USD method, tie design is given here. So this is all about this column design sheet. I think this sheet will help you in column design purpose, and that's it. This concludes the tutorial here, and up next I will discuss about beam design with Excel. So let's see some preview of that sheet. This is the beam design sheet. I will discuss in the next tutorial. Until then, bye bye.